Hello, I'm Matt and welcome back to DIY Perks. In this video I'm going to be showing you how to build your very own desk PC with a design that brings to the table some very useful real-world benefits. Now, building computers into windowed desks has for a while now been a great way for PC enthusiasts to express their interest in hardware as a form of art. But unlike this, the typical design is to have all of the components built into a bulky desktop, which doesn't bring to the table, pardon the pun, many practical benefits apart from showing off the hardware. However, with this particular design, having all of the hardware in a rear chamber, it means that the desktop itself can be thin and elegant, and can be folded away when the PC isn't in use, which is perfect for smaller spaces where a large desk area like this would otherwise be impractical. Despite this minimalist elegance, the component chamber itself is absolutely vast, allowing for all sorts of powerful hardware to be mounted inside. Now, this is where another element of the design comes into play, which is silence, as this chamber is completely airtight, which locks in any noise generated by the components. However, as they are so powerful, they do generate a lot of heat, and that heat does need to be removed. So it utilises water cooling to take the heat away from the components and into two large radiators in two side units, and these get then vented into the surrounding air. This works extremely well, and it even tackles tricky issues like pump noise and graphics card coil whine. And I'll be showing you the thermals and sound emissions at the end of this video, and my goodness, it's impressive, especially considering the amount of heat that it has to deal with. So it's elegant, provides plenty of room for high-end hardware that can be cooled silently, and it can be made extremely compact in a room when folded away. Now, this video has a lot in it, ranging from custom water blocks and cable sleeving to woodwork and DIY capacitive buttons. So grab yourself a drink or a snack and sit back and enjoy. Now, before we get going, I'd like to say a huge thanks to these brands who have sent various components over for the build. I'll be introducing these individually as we go along, and if anything strikes your interest, you can find links to each of the products in the description. Also there you can find a 12-page guide to help you to construct the main body of the case, which includes measurements for it and extra tips that couldn't make it into the video due to time constraints. It'll make building the case much easier, so have a look in the description for more details. So the material I suggest using to build the case itself out of is 18mm thick MDF, as it's readily available and very dense, meaning it's very good at blocking noise. It is a very dusty material when cut or sanded though, so if like me you don't have a workshop, work outside and wear proper breathing equipment, as the dust is definitely not something that you want to be breathing in. To make the central component chamber, you'll want to cut out a large piece for the back, followed by two side pieces and two top pieces. Quite importantly, these side pieces need to have some large cutouts made in them for some connector panels to fit into later, which extend all of the connections to provide access to all of the ports. This is because the central component chamber will be completely sealed and would otherwise block access to things like the monitor outputs and USB ports, etc. So having these extended to some panels makes a lot of sense. I also recommend that the top piece has a cutout in it too, as this will allow space for buttons or switches to be added, which I'll go into detail about later. Before fitting these together, however, it's important to work out a suitable component layout. Any mounting holes need to be marked onto the wood with a pencil and then carefully drilled out, but not all the way through. They just need to be deep enough for some threaded inserts, which are screw-in mounts that allow you to use fine thread machine screws in comparatively soft surfaces like MDF. These particular ones are for the motherboard to sit on, so at this point some PCB pillars can be screwed into them and the motherboard perched on top to check accuracy. I also made provision for some extra long pillars just next to the edge, which will later be used for securing the expansion cards. This process needs to be continued until you have mounting holes for all of your main components, though like me you may need to adjust these later or add some more as the design evolves. Once you're happy with the positioning of everything, the holes can be temporarily bunged up with blue tack to stop any paint from clogging them up when we reach that stage. For now though, we need to mount our pieces together, and to do this we can clamp them to the main sheet and flip the whole thing over so that we can drill some pilot holes through them both. The piece underneath can then be removed, and the holes on the main sheet can be widened to turn them into through holes, which let the screws through without resistance. They also need to be countersunk so that the heads can sit below the surface. With that done, the side piece can now have some wood glue added along its edge, and then be pulled into place with the screws. After the remaining side pieces have been added, you should have a very sturdy central compartment, which is comparatively vast for a PC case, leaving plenty of room for the internal components. So after filling and sanding the countersunk screw holes, it's ready to paint, and we're going to start with some MDF primer, as MDF is a very absorbent material, and sealing it is very important for proper paint adhesion. With at least 2 coats of this applied and dried, we can now add some oil-based undercoat. Being oil-based, it very quickly builds up a relatively thick layer. This means that after giving it 2 coats and leaving it to thoroughly dry for a day or 2, it can be sanded down. If you try this when the paint hasn't completely dried, it will gum up the sandpaper, so it's much easier to wait a while so that it comes off as fine dust. Now, as this is quite a large surface area, I used a small palm sander, but you can do it by hand if you like, and if you take your time, you can sand it to an almost plastic-like appearance, mimicking a powder coat job. This makes it a great surface for the final top coat, and I'm going to use glossy spray paint for it as it's quick to apply. But as it's cold and windy outside at the moment, I'm going to have to do it indoors, protecting the room and containing the paint mist with some plastic dust covers. With that done and dry, I also added a few threaded inserts around the edge so that a front panel could later be screwed in place. And to the side I mounted a power strip which I could later plug things into to keep the wiring neat. Now, part of the design is that there are 2 side units that stagger the central chamber. These need to be built separately to make them removable so that the case can be dismantled and be easier to transport if ever needed. Their job is to primarily house 2 large radiators that cool the liquid in the water loop, but they also hide things like the power strip and also all of the input and output ports for cable routing purposes. These units can again be built out of MDF and screwed and glued together. Remember, there are plans for these in the description which should help you cut them out properly, including the position and size of various holes like these, which will later be used to bolt the unit to the main chamber. The countersunk screw holes on the front of this can also be filled with wood filler and sanded flat, after which it can go through the usual painting process of first being undercoated with MDF primer, then a couple of layers of oil-based undercoat, after which it can have a good sanding down and then be painted with the final colours. I painted the inside with black gloss, avoiding spray paint this time as it was a bit of a faff, and the outside I painted with a lovely slightly blue shade of grey, again in gloss as this is my chosen outer colour. Looking good. As you can see, they've got various openings and an internal brace for adding support behind where some right angle hinges can be mounted. These will later be used to allow the desktop to be hinged up and down, and can be easily unlocked to allow them to be folded away. They're available on Amazon, so I've put a link to them in the description. These side units can now be bolted to the main enclosure. To ensure an airtight seal around each bolt, I added some black tack just under the heads, which will make it completely airtight once it's tightly bolted from the other side. Now that they're secure, it should be looking something like this. The blue tack plugs can now be picked out from the mounting holes and the pillars screwed back in place. With that done, it's finally time to start adding the components. The first one I'm going to add is the power supply, which is a high efficiency unit that's been sent over from Seasonic. It's very powerful, capable of delivering up to 600 watts, and impressively it can do this silently, as it's entirely passive. To mount it, I added some carbon fibre effect vinyl wrap to a short aluminium right angle, and then used this to secure it in place. With that done, it's time to start working on the water cooling loop that's paramount in this whole design. All of the components I need for this have been very kindly provided by AlphaCool, who design and manufacture all sorts of water cooling gear, from radiators to water blocks and reservoirs. Big shout out to Dave, who was very helpful in getting the ball rolling on this, as the project relied so heavily on these components. As you might expect, one of the first components to consider is the pump. Generally, these allow for different tops to be added for various port configurations, and I'm using a solid brass one here, capping off the ports I don't need. Now, as it's a pump, it obviously has moving parts, so will naturally generate vibrations. As I'm aiming for total silence for this build, it's important to physically isolate the pump so that these vibrations won't be transferred into the case, getting amplified in the process. This is surprisingly important. Imagine when a phone is vibrating on a table. There's a big difference in sound level when it's touching, and it's the same principle here. So the first step in isolating the pump is to 3D print a little bracket for it and mount it to the back. We can now get 4 long pillar supports and add some heat shrink over them to give them a matte black appearance, after which they can be screwed to the bracket. Some additional tabs need to be added to these as well, which just adds some holes through which we can thread some elastic to suspend it from 4 more pillar supports, which makes for superb acoustic isolation. Now, as you can see, I actually mounted this to a backing platform, which adds a really cool lighting effect. To make something like this, it's just a case of covering a sheet of frosted acrylic with some vinyl wrap, and then carefully cutting your desired light pattern out on the front. As you can imagine, there are limitless possibilities here. To light up your pattern, some LED strips can be stuck onto the back face down, and slightly offset by a centimetre or so that they don't shine directly through the pattern, but rather get scattered and light the pattern up in an even way. Now, as the vinyl isn't terribly thick, you may want to add a couple of layers of it to prevent any light bleeding through where you don't want it. So that gives you an example of how to do it, and it's simple yet effective. Whatever you come up with for your design, it can just be screwed to the back of the case where you want it, and you can add as many of these as you like. Just be creative and have fun. So with the pump now mounted, the next thing to add is an internal radiator, and the sole purpose of this is to keep the air temperature inside the case as low as possible. This is because the case is completely airtight, so the air temperature would just go up and up from residue heat sources like the power supply and hard drives. Having this radiator inside, with its own fans to push the air through it, means that the internal air is kept close to the temperature of the water in the loop. I'll be doing some thorough tests of this later, so stick around for that. To again isolate any vibration noise, from the fans this time, it's important to suspend the whole thing using elastic from the top of the case, using a sponge and some sticky back velcro at the bottom to keep it vertical. Again, this should work really well, but we'll have to wait until later to know for sure. The next component to add is a reservoir. These are very useful to have in a water loop, as they make it much easier to fill, and they also help to catch any air that might have gotten trapped inside. To hook this up, I'm going to use some EPDM rubber tubing, which is often used in vehicles where longevity is paramount, as it doesn't leach anything into the water over time. Visually, it's not as nice as glass or acrylic, but it is my choice for this build, not only because of its longevity, but also because it provides a soft link between the pump and the remaining components, aiding in noise reduction. It can simply be cut to length with scissors and then pushed into what are called compression fittings, which feature a barb for it to go over and a cap that gets screwed down on top, making an extremely tight seal. I mounted the top end to one of the ports on the radiator and the bottom end to the intake port on the pump. An additional pipe was left loose to later be used as a filling pipe. The other port on the radiator follows a short length to the outside of the enclosure through a hole. This will later be hooked up to another much larger radiator, but more on that in a bit. As you can see, the whole thing is very wobbly, but that's what I'm after, as it should be acoustically isolated because of this. So the next component to add at this point is perhaps what you'd call the heart of the PC, which is of course the motherboard. This has been sent over by ASRock and is based around Intel's high-end X299 platform, which has been designed for high core count CPUs, quad-channel memory, and plenty of PCI Express lanes for a lot of connectivity options. Now, as X299 processors demand a lot of power, the motherboard has an extensive power delivery system which is cooled by these heat sinks. However, to stop this heat from being dissipated into the air inside the case, acting like a residue heat source which the internal radiator would have to deal with, I'm going to cool it directly with the water cooling loop, so that the heat can be transported straight out of the case instead. After removing the heat sinks, however, I realised that I'd need to make a custom water block to make good thermal contact with the heat producing components, as they are at varying heights. To do this, I first cut out 2 short strips of copper and primed them by adding a thin layer of solder to each. I did likewise with a larger strip, which had various holes cut out in it for mounting purposes. I then dabbed on some flux and clamped them together in a vise, carefully heating them up with a blowtorch. Once they hit the melting point of the solder, they welded strongly together, becoming like a single solid block. Once cooled down, it just needed to be cleaned up. After which, one of AlphaCool's small general blocks could be screwed in place on top. When the water passes through this block, it will pull any heat away, keeping the entire thing extremely cool, which is great news for the components. I later tested this with a thermal camera, and as you can see, it does a great job despite being custom made. With that done, the processor itself can be mounted. I have my supporters on Patreon to thank for this, as it was with these funds that it was purchased. Remember that you guys get the entire project resources for free, so check out the special Patreon page to download them. For those of you who aren't patrons, but want to support the channel and get these free files, as well as those of past, present and future projects, you can find a link to the Patreon page in the description. So to cool the processor, it too needs a water block adding. This is one of the largest ones that AlphaCool makes, and it should keep the temperatures in check very nicely, which is important as these particular processors are known for getting extremely hot due to how powerful they are. So after bridging both water blocks with a short interconnection tube, the motherboard itself is almost ready to mount. But before I do, I'll add one more component, which is an ultra-fast M.2 SSD from Western Digital. This has a huge 1TB capacity, and thanks to its insanely high read and write speeds, should make the system feel extremely snappy when in use. To install it, it's just a case of screwing it to the motherboard like so, after which the whole thing is ready to be mounted into the case. As we added the pillars for this earlier, it goes in without any problems. So now it's time to add the graphics card, and the one I'm going to be installing is an RTX 2080 from Zotac, which they have very kindly sent over to support the build with. This is an absolute beast of a card, and is one of the fastest currently available, which is great for heavy workloads like GPU accelerated video rendering, CAD or modelling work, and of course gaming. It's got a very capable cooling system already, but as I want to water cool the card, I'll have to remove it to install one of AlphaCool's compatible blocks. Just like with the motherboard, it's not just the processing unit that needs cooling, but the power delivery system as well. This is where the water block really comes into its own, as it can make direct contact with these components to keep the temperature of the entire card in check once it's screwed in place. This can now be installed on the motherboard and linked into the loop. To support it, and any other expansion cards I might want to add later, I also screwed in place a little bracket at the bottom for it to attach to. So at this point, the main components have all been plumbed in, and the flow goes from the pump, past a T-splitter, which will be used for drainage if ever needed, up into the graphics card, down into my custom motherboard water block, over into the CPU block, and then up from the motherboard and out into one of the side units. This will later be connected to a radiator, but before that gets added, we need to solve the unfortunate situation of all of the I/O connections being marooned inside the case. To make them accessible externally, I bought a ton of short panel mount extension cables. These include DisplayPort extensions, USB extensions, and even some LAN ones. I mounted these to the MDF panel I mentioned earlier, and I sealed around them with some Sugru to make them airtight. This could then be slotted into place and plugged into the various ports. Now I also made an audio panel in a similar way, featuring speaker and headphone sockets, some auxiliary inputs, as well as XLR microphone sockets. This one just slotted into the opposite side behind the power supply, and I'm not too worried about the messy appearance as it'll be hidden later by the front panel. With that done, it's time to mount the radiators that are responsible for expelling all of the heat that the PC generates. And as you can see, they are absolutely colossal, which means that they'll be able to do their job very effectively. They can just be mounted into each of the side units like so, and linked into the loop. Now these radiators have drain ports on the bottom, which will come in useful if I ever need to change the coolant. So I utilised them by attaching a short length of tubing to them with some stop valves on the ends, which I can just keep behind the unit until required. Before moving on, I also fitted a bank of fans to the inside of each side unit. These fans barely spin at all and are completely inaudible. They just provide gentle pressure to encourage the air to circulate through the radiators, and we'll be seeing how well they keep the system cool later on in the video. Some removable panels finished off the look nicely. I also added a fill port to the remaining reservoir tube and suspended it with some elastic, which, while not particularly pretty, does do a functional job of preserving the acoustic isolation. Now it was just a case of adding the few remaining components, like the hard drives, which were suspended from some more pillars, and some custom braided power cables. Now these take a lot of time to make and route, but they're definitely worth it for the aesthetics. To make them, all I did was cut through one wire at a time on the original power cables and solder an additional length to it as required, as the originals weren't quite long enough. I then covered the joins with heat shrink, threaded on the sleeving, and rejoined the wire at the other end. Doing these one at a time ensures that there are no crossed connections, and I hope you'll agree that once they're finished they look really good. They were all kept neat and orderly with some 3D printed cable combs, and you can find the files for these included with the project resources. So the last primary component to add at this point is the memory, and Patriot have sent over a whopping 64GB of their Viper RGB line specially for this build. This is very fast RAM, and features internal RGB lighting which can be configured to light up any colour you like with various effects, which really does finish off the lighting element of this build and looks absolutely awesome. Now for most builds that would have been all of the components done and dusted, but as I like good quality audio, I'm quite excited as Burson Audio have sent over for the build one of their powerful audio amplifiers, the Burson Audio Bang, in addition to their new and improved headphone amplifier and DAC, which is the Burson Audio Playmate. I used the previous version of this in my last build, the Wood and Rope PC, and have been consistently impressed with the sound quality. What makes these units unique in addition to fantastic audio quality is that they've been designed with op-amp rolling in mind, meaning that you can change the sound characteristics by simply swapping them out. Burson have a selection of these that can be purchased separately, allowing you to fine-tune them to your personal taste. Once I fine-tuned mine, I mounted them to the sheet of acrylic that had gone through the special lighting effect process earlier, which in turn could be mounted to the inside of the case. It might seem odd to have access to the volume knob restricted like this by locking it inside the case, but the Playmate does support a remote control, so I can just adjust the volume that way as needed. To finish the build off, it's time for some woodwork to make a hardwood top for it. For this, I got a length of MDF and stuck some ash hardwood strips around its perimeter to give it the appearance of being solid ash from the sides. On top of this, I then glued down several ash planks and clamped it all in place until it was set. As its surface ended up pretty rough, I took the blade out of a plane and scraped it along the top to flatten everything off. And to neaten up all of the edges and unify them, I trimmed them up with a plunge saw, and then sanded the whole thing down. I then drilled a few required holes in it and gave it 2 coats of oil to protect it long term and to deepen the wood's character, making it look absolutely stunning. Now before attaching it, I ran some black tack around this gap so that it would make a seal to keep in any noise once the top is screwed in place. This gap allowed for access underneath these 3 holes, which have been made for some brass caps to be fitted into, as these are actually going to be rigged up as capacitive buttons for various functions. To achieve this, we can use these tiny little capacitive PCB circuits, which detect the presence of skin and trigger a voltage output which can be wired up to flip some relays to achieve the desired switching. Now the behaviour of these boards can be adjusted by bridging these little pads on the PCB, which changes it to function as a latching switch instead of a momentary one, which is very useful functionality. You can find links to these super cheap boards in the description, as they're always useful to have around for implementing into projects. I simply glued them in place underneath the brass discs, and they detect whenever the brass is touched, which in turn flips some relays. I've wired up one to turn the PC on, followed by another to power up an XLR microphone preamp, and the last one powers up the Burson amplifier, redirecting audio from the headphones to the speakers, making them quick and easy to switch between. With that done, the loop can finally be filled. I used a premix for this, as it has additives inside to prevent bacterial growth and to discourage corrosion. Now it was quite tricky to get this filled without any air pockets, but once it was done, the pump could successfully move the water around the loop, which cools all of the components and looks absolutely fantastic. So with everything now sorted on the inside, it's time to seal it up. For this, I made a frame out of MDF for a glass panel to fit into. The glass I'm using is a double glazed unit, which should help to block out any noise, and is of course toughened. I simply glued it into my frame and sealed around it with some more adhesive. Around the frame's edge I then stuck down some draft excluder, which will make yet another airtight seal once the frame is tightly screwed in place on the front of the case. Now, with the case being so shallow, it's not particularly stable, but that's okay as it's intended to be tied into the wall with some screws, after which it becomes extremely sturdy. The last thing to do is screw on the folding desktop, which was made in exactly the same way as the smaller shelf, completing the build. So with it complete, it is conclusion time. Was it all worth it? Now for me, that answer is an absolute yes, despite the amount of time that it took And it took a long time. I've really enjoyed using it the past month, and it's the best machine I've ever used. I've got a high refresh rate monitor here on the wall, a low latency mouse, and it's just so slick and responsive to use thanks to the high-end hardware as well. Now it also does this silently. During use you can't hear it. There is a very low level hum from the 8 fans that are spinning slowly, but you can only hear that if you duck down underneath the desk, and obviously that's not something that you're generally going to do during use. But here is an example of that to give you a general idea. What's most impressive about this is that it's fully maxed out with Thermark and Prime 95, both at the same time. So this isn't idle, this is fully maxed out. That's really impressive. Now, one of the reasons for the silent operation is of course the glass, as it locks in any component noise. Here is a before and after example, and do keep in mind that the microphone is at the exact same volume level between these recordings. Very impressive results. Now, a side benefit of the component chamber being completely sealed is that it will never get dusty, which from an aesthetic point of view is really nice. Now, another side benefit, which I may check out in the future, is that it would be possible to use a water chiller for extreme overclocking. And this is because all the moisture in the chamber could be evacuated, meaning that condensation would never occur, which is usually one of the biggest problems when using a chiller. So let me know in the comments if you'd like to see that. So in conclusion, I love it. I think it was worth it. It's a super machine to use, and I think it's interesting as well, just as a concept. And I hope that you have enjoyed watching the build process in full, and I hope it's given you some inspiration of something that you might want to do yourself, even if it's not specifically this design. Though remember that there is a PDF file in the description with measurements and extra tips that will help you along in making it. So before I go, a final huge thanks must go out to the various manufacturers who have sent their products over to use in this build. They've been very patient because it's taken a long time to get to this stage, but I hope that they agree, and I hope that you agree, that it was all worth it. But other than that, I'm Matt, you've been watching DIY Perks, and I hope to see you next time. Goodbye for now.